Hello, it's me again. Today I'm going to kind of go through the model part of Deepstream 6 and what it takes to, like if you want to run your own, if you want to train a model on your own data set, kind of how that is done and then how to actually get it, what it needs to take to get it onto the Nano or the Xavier NX to like run it and stuff. So what we're going to do is we're going to start out with a very simple Deepstream app, the Deepstream app, source 8. It's right here in Deepstream samples config Deepstream app. It's this one right here, text one, and what it is, I've got it up over here, right here, and basically all this stuff, most of the stuff in here is basically compiling the pipeline. It's like what's coming into it is going to be a file, webcam, IP camera. How to do the classifications, the bounding boxes, and this kind of like puts it all together right here. But the thing we're really going to go after is this: the model engine file. This is the engine that's going to do the inference on the stream that comes in. So those things we want to kind of really pay attention to is this model engine file right here. That's going to run in the primary detector nano folder. And the other one is the config file. And that basically kind of tells the program how to build this right here. And another thing too is like when you, let's say you use the Transfer Learning Toolkit or TAO to build your custom model, it will go right in here, and you'll basically tell this application run the model you've made, don't run this one. So anyway, so let's go back to this is the model engine file. That's going to run the inference. The config file is going to tell it how to build it. So we're going to go to the config file. There's this run right here. And here's the config file right here. Config int for primary nano text. And I believe that's this one. And I've got it up over here. Now, what it does is, when it goes to here, it's going to say, take this ResNet 10 Cafe model, take the ProText and the labels, and build this engine right here. And when this engine's built, have this application use it for inference. So let's just go to where we're gonna, like here, where all this stuff is at. So if we go to primary detector right here, models, primary detector nano, ResNet 10 Cafe, models, primary detector nano. Now what we have here is we have the ResNet 10 Cafe model right here. That's the model that NVIDIA has already pre-trained to run in here. It's already been pruned and modified to run as the Deepstream model. And then here's the ResNet, the ProText. I'm not sure exactly what this is. I think this is how it wants to be built. And then here's the label text right here, like this. You go label text. So basically, this has only been trained. This model's only been trained on cars, bicycle, person, and road sign. So let's close that down. Go back to this. So anyway, so that's what we're going to do. What I want to show you is once we start this application, it's going to take a while for it to start up because it has to build the engine the very first time. If the engine's not here, because what it does is says, look in this location for the engine. Look in this location for the engine. If it doesn't find it, then build it. So we're going to go up here. We're going to run this. I'm running an Xavier NX. So that'll tell you kind of the speed we're going to run. Now this is go ahead and put it together and compiling it. And watch down here. It's going to take all this and it's going to build the engine for the first time. Now, like I was saying, like all these other things over here in this text file, this is just like for the how the display is going to work, how how what's up here. Let's go to the top. This is like how it's going to look like when it displays how many columns for the display when the image comes up. What kind of memory device it's going to have, where it's getting its input from. We're running this sample stream right here. This is how it displays. The other things is like if you want to save it to a file or you want to save it to like send an RTSP stream out. And this is like all this is how the bounding boxes, how big they are, the colors and stuff like that. So a lot of this other stuff is just for building the pipeline. You know, it kind of, the model comes in for inference like down here. So as you can see, we're still compiling up here. And once it compiles, this engine will be built, ResNet 10 Cafe B8 group, and then it'll run it. By the way, this B8 right here stands for the batch size. So it tells us like kind of what it is. And it's the Cafe model. This is the model that NVIDIA has trained for these Deepstream applications. That's to say, once we get done here and we kind of good idea how this works, we're going to go over to the Transfer Learning Toolkit and show you how to train. Here we go. Let's see. Let's move this. I see I'm VNC'd into it, so it may seem choppy. So I'm trying to get it all in one. As you can see, we're running eight frames here, 8 views. They're running like 50 frames a second, all of them. You know, so there's 30. So I mean, it's doing a good job. So, but let me show you this. So we're gonna kill this. Now, if you noticed, this engine was built right here. So this is the inference engine that this model is going to use. Now, every Deepstream application does this function right here. It takes whatever it says in the config inference primary target. It takes all this and builds this inference engine. Now, all the other applications, the samples, they do the same thing. Now, there might be a little change. Like there's some YOLO ones here where there's like 50 labels in there, and it uses a different type of configuration. And then but if you notice, this engine's built now. So basically it's going to say down here, go get this engine to run inference, and if you don't have it, build it, but it has it. So what happens, this will run a lot faster now. It'll start up a lot faster, excuse me. Because see, it starts up. It doesn't have to build the engine since it's already there. And then we get the same exact thing. Same speed, everything. Now, what happens is, let's say you want to train a model on custom data, your custom data, and you don't want to use NVIDIA, what they have here. So what you do is you have to build your own model right here and put it there, and then put your labels there and whatever protext you have, and then when you run this, it will create a engine out of what you have. Now what happens is this has to be a Deepstream configured model, or it doesn't know how to put it together. That's what it's looking for. Or the other option is I'll show you when we do the Transfer Learning Toolkit, that like you can actually just build the engine outright, and just throw it right in there. So you don't have to have this build it. You'll build it yourself and just throw this in there. So it goes right to your model that's been custom trained on your images. So that's pretty much here what we're done now. I'm done with like how the Nano or the Xavier gets the inference engine, builds it, and runs it. So now I'm going to go over to the Transfer Learning Toolkit, and I'll show you what it takes to like build a custom data set and model that you want to deploy on, let's say, Xavier NX. So let's kill this. So anyway, what I've done is I've already brought up like the Transfer Learning Toolkit. Now they call it TAO now, but it used to be called the Transfer Learning Toolkit. So that's just the same thing. So what it is it's a bunch of NVIDIA has pre-trained a lot of models that you can use, and then you can take your the data that you want to train on, and you can run it against it, and it's called transfer learning. So what it is you don't have to spend thousands and thousands of dollars and hours retraining your models just for your data set. What you can do is NVIDIA has already done that. So what they do is they take transfer learning, and what they do is they use what the model has already learned, and they just tell it, okay, here's some new data, learn that. On what you know, just learn this. So, like this, when I do this transfer learning toolkit, it generally takes me like 24 hours to train what they have to what I want. So, and these are all the things that they have. Let me see if I can get it right here. Let's see. Like right here. These are a lot of the pre-built stuff they have. Vehicle net, people net, license plate net, and they've already built these with. So these these models have a classification and object detection in them. And then here's their object detection part of it. DetectNet, YOLO. I like YOLO. That's my go-to one, and all this stuff. And what you can do is the Transfer Learning Toolkit is you can combine a classification model and an object detection model to like produce something that's really good. That's what I do with the YOLO. It basically on the Transfer Learning Toolkit, like the YOLO 3 here, it uses a ResNet 18 as its like backbone for its classification. Then it uses YOLO for the object detection. So there's all these combinations that you can put together to build whatever you not. Like a lot of what they've done is they've built examples that are pretty close to what everybody uses, and that they're so close to it that you can take your data and just run it through the Transfer Learning Toolkit and retrain these existing models for what you have. So these are all the things right here. I've already got it running. I've got an example up already. I've got the DetectNet example right here. And basically what this does is this is just one of many here, right? Let me see if we can go over here. These are all the Jupyter Notebook examples. They have a new one. The new one where the example detects action. That's cool. That's pretty nice. The DetectNet V2, this seems to be their base one. A lot of their models are based off this right here. FaceNet, Faster RCCN, Heart Rate, GazeNet, Mask RCCN, that's pretty cool. SSD, that's another one, a single shot detector that people like. Like I say, so what you can do is you can build your model with a classification and an object detection. I use YOLO 3. So anyway, so let's get to like basically how this is done. What you do is you pick whichever application you want in here that you're going to use. Because right now I picked the DetectNet, and this is the file with the Jupyter Notebook, and this is the Jupyter Notebook running. Now, what it is to retrain this on, what they've done is they've trained it on their own data. And this is the data that they've trained it on. Let's go back here. So this is what they've trained it on. And like I say, this is the Kitty format. So they've trained all these models pretty much on this these items like cars and trucks and bicycles and stuff like that. But like I say, this data to train this trained data set can be used for anything. And there's other data sets in, or other models in here, excuse me, that are trained on much other things. Like the YOLO model is trained on 70 items, from like pigs to cars and all that stuff. So these are the images that they've used to train their models. Now what happens is, if you wanted to, you would put your images in here that you wanted to train. You would remove these and put your images in here, and then like you would have to have a kitty annotation. Here's training, here's the images. Okay, there's a person there. Let's close that. And then here's the annotations for that, like right there. Pedestrian. So that's the annotation for the image we just saw that they would use to train with. And like I say, the Deepstream, the Transfer Learning Toolkit, or TAO, has to have its annotations in the kitty format. Because what happens is it takes that kitty format and the images and it turns it into TFT records, and that's what it does. Now, a lot of, if your images are annotated in like a Pascal VOC or YOLO or something like that, there's a lot of things out there, and I do have some on my YouTube page that shows you how to convert them over to kitty. And then they also have the synthetic data generator that comes with the Omniverse that they just came out with. It converts its images into kitty format, so they can be transferred right over here to the TAO Toolkit right here. So basically, you would just take your annotations and your own images and stick them all here. Okay. And what happens when this runs? Then you start going through the Jupyter Notebook. Basically, you mount your drives, and then the launcher's already in here. Prepare your trained data set. This basically looks to make sure you have the images and labels. Then just sorts them into train and test folders. That's basically all this does. And then what happens is it takes the kitty formatted data set and turns it into TF records, and that's what the TAO Toolkit will use as its training. Like here, this is what it'll use as its training. And then what happens is right here, you can, this is where you download the models. Hold on, I gotta get my dog. This is where you download the pre-trained models. Like for example, let me see if I can show them all. Okay. Okay, so I got to get my key in that I don't. Yeah, I have to get the proper key. Well, what it does was, and in my examples I showed you, you probably have to look in the other examples. What this does, this will bring down the list of models you can choose. So you can choose, you know, this defaults. A lot of these default to ResNet 18. And like I say, I'll see if I can fix this. But if not, if you go to my other tutorials on this, it shows kind of what it produces and how you could check them. So once you pick it what you want, then you know, like the ResNet 18, and then what you have to do is you have to go into the specs directory, and like let's see right here. So to do our training, our TF records right here. Now basically this is what we're going to do. This takes the images that we have, the kitty formatted images, and this builds the images into what the TAO needs to train on. It you know, takes them, randomizes them, splits them, and does all these things, and then it puts them like here. So it does this to get your images that you put in like ready, and then to do its training, let's see right here. To train, right here. And right here, this is the training format. This is what it uses to train. It shows where everything's at. Like I say, if you put you put images in here, you would change these to your images. Let's say you put like cats and dogs in there. You would change these to cats and dogs. Everything else would be pretty much the same size. I mean, everything would be pretty much left to its own. The only thing you would change would be like the what the annotations are called, like dog and cat or whatever you have right here. Everything else pretty much stays the same. And then once you do that, then you run it through its training. Then what happens, this is where you're training. And you can set how many GPUs you got, whatever. If you have more, I've only got the one. So then here it starts its training. So this usually takes, I've got a GTX 1080 Ti, and this will take me like 8 hours to just train the first set of data. And what it is, it's not really training it. What it is like called transfer learning. It's using the existing model, all the nuances and stuff that the existing model knows to look for, and it just takes your whatever data you have put in there, and it tells it to use. It tells the model, use what you know to now look for these objects, and it works really well. I mean, you don't have to retrain this model for like days on end, because NVIDIA's basically already done that for you. And then right here it goes through this, and then you can evaluate the model right here and tell you how well it's trained. You can go and look at all the epochs and see which one is the best, and you can choose which one is the best for the best inference. And then you prune the train model. This is like where it's being modified to run with Deepstream. So it takes the model that it just generated and it prunes out. I'm not exactly how it does prune it, but it cuts down the size of the model, and that's how Deepstream gets its speed, because it now has a slimmed down model that still can do very good inference. So it does right here. This is where you prune it, the model, and then once the model's pruned, it has to be retrained. So they go ahead and they retrain it again. Like I say, this takes another 18 hours or 8 hours. Sorry. And that happens, you evaluate the trained model. And what happens, it'll come back with the evaluations that tell you how well you've trained, how good your model is, how good its inference is. And then what happens, you down here, it'll take the images you have in your test locations, and it'll actually run inference on them. So it'll give you a good idea, if it's trained well enough to now to detect the new objects that it's been trained for. And here, this is where it just shows up images, what it wants to do. And then here's the part. Now, so you're pretty much done with your training, and you've got everything ready to go. Now, what happens though is we want to run this on the Xavier NX or the Jetson Nano. So what you do is this will export the model and get it ready to be moved over to like a Xavier NX or Jetson Nano to be run. So right here, you run this, you export the model. You run the int optimization on it because you're going to need that. You're going to need that over here. It's the int 8 calibration file. You're going to need that over here to build your new model. And then right here, down here a little farther, you build it like this. So what happens is this section right here, you can build it. Now a lot of times this part right here and the part below it, you generally want to run this on whatever device you're going to export it to, like a Xavier NX or Jetson Nano, because then it builds it, it customizes it to the unit you have. So on this one, you can export it, and if you put it over into the Nano, like I say, it'll use it to generate the new engine. Now down here, you can actually generate the engine right here. So what this does, this generates the engine that you need. So you don't have to, the model on the Xavier NX doesn't have to get all the configurations and produce a new engine. You basically take this, generate a new engine, and replace the one that's in there. and then it works just fine. So you have a new engine that's built, trained on your new objects, and that's been built inside the Xavier NX or Jetson Nano, so it's built to those specifications. And then down here you can verify the deployed model, how well it works, and convert it to quad. I'm not too sure about this. I don't do this because like this works really good for me, so maybe I'll just try this one day and evaluate it against like how it's always works for me. And this is basically the same thing. This is your generator tensor RT engine, and here you're doing this. This is basically the same thing, but with in the quad format, which is quantization. It's called quantization. So I mean, I think someone better explain that than me. And then you have to do the int 8. So if you want to take all this and bring it over to the Nano, have it generate a new engine, you can do that. Or you can, like I say, just build yourself a quad engine and get it over there and replace the one that's in there. Now, I know I jumped through this really quickly. I just wanted to give a kind of a quick, like a rundown on how this all works. And but if you want more detailed examples of this, I have tutorials that are very detailed on how this all works, and it shows the results of all these things. But I just wanted to show that, like, what it takes to get a Jetson Nano or Xavier NX to run on somebody's custom data set. So, like I say, the Jetson Xavier NX have their own custom models already built for them that NVIDIA's done. And basically what you're going to do, and what this transfer learning toolkit does, use those as existing models, and it just retrains them for the new data set that users want to use. And then other than that, then it generates the engine, and it generates everything you need to just place it in the Xavier NX or Jetson Nano. Like I say, I have tutorials that are more detailed if you really want to know the details of how to actually do it and how to actually deploy it on Xavier NX. But this is just like a quick rundown of kind of what it is. Well, anyway, I hope this didn't bore everybody. So, and it is helpful for people. All right, thank you. Bye.